Okay, all right, let me share my screen. Okay, can everyone see my screen now? Can everyone see the screen? My screen.
Yes.
Okay,
Yes.
all right, good. So this unit here, we're gonna talk about probability. Okay, so the model 3 and 4 will be the probability. Probability is a big concept in statistics, right? So the objective for this one here is we need to understand the basic concept, right? And then how to counter the probability, okay? And then we have a different type of the probabilities. Sometimes you have to use the addition, sometimes you have to use the multiplication, and there's also conditional probability, okay? So we have a condition, we have a multiplication rule, we also have an addition rule. So that is a little bit more calculation from this unit. So basic concept of the probability, right? And we usually just trying to see, so what is the probability basically? If you think what's the chance gonna rain tomorrow, right? And that's the probability. So we say maybe 30% chance of raining tomorrow, all right? So your probability will be 0.3, right? So usually probability is between 0 and 1. All right, so when we talk about probability, we usually don't want to use the negative. So probability usually is between 0 and 1. So 1 is also 100%, right? So 100% will be the maximum. Okay, so we don't say the probability is more than, 100%. Sometimes you will, heard people say, "Oh, I'm 120% sure," things like that, right? But that one, I mean, you heard people saying that, but in probability concept, that is not a correct one. Okay, so in probability, the maximum will be 100% that way. All right. And then we also need to be able to use called a tree diagram. Okay, we're gonna need to be able to drop a little bit tree diagram in here. So what is a tree diagram? We're gonna talk about it later. Okay. All right. So probability experiment. Okay, you can toss a coin, right, or a penny, and if you toss a penny, usually when I have this in-person class, I usually bring a lot of pennies and let people doing the experimental. And then you can flip 10 times and then trying to see how many times you got a head, how many times you got a tail, that kind of thing, right? So that is the probability. And like I said, if I only ask you, if you toss a penny, what is the chance you're gonna get a head? Anyone? All right, can you write down in the chat? If you toss a penny, what is the chance you're gonna get a head or a tail, whatever? Okay, 50%, one half, those are all correct answer, right? Yeah, the one half is also the 50%. Okay, so that is called a theoretical. Okay, on the paper, yeah, if you toss a penny, you will get a 50% head, a 50% tail, right? So this one, usually we call this is on the paper. If you do this one at home or after class, you can do a little bit. You can flip a penny, you can flip a dime or a nickel, whatever, or a quarter, anything you can flip, right? Probably not your cell phone that way, but you can flip anything like with two sides, and then trying to see like, how many times the head come out, how many times the tail come up. You will if you do more than one time, right? I usually have like a different group, like a 5 or 6 group, and then each group will come out different answer. Okay, some group will come out with 2 tails, some people will come out with 7 tail, some of them will come out with 6 tail and 4 head, things like that, right? So those kind of thing is called events. Consist of one or more outcome is called event, right? And then the result of the single trial is called the outcome. When you flip a coin, right, or a penny, and then you're gonna get a head or tail. So that is the outcome. The outcome will be a head or a tail, right? And when you're doing this one, this is the probability experiment, right? This kind of probability experiment you can count or you can measure, you can using a survey, and then you can tally that, right? And this event here, can be consist of one or more outcomes, okay? And then another one, this is relatively new, which is sometimes people probably never heard of it, called sample space. Okay, what does sample space mean? That is a terminology in statistics, okay? Basically, the sample space is the set of all the possible outcome of the probability experiment. So for example, if you toss a penny, right, and then you will get a head and you will get a tail. So that is this head and tail. This is called your sample space. So I have two outcomes in here. So my sample space is equal to 2, right? Can be head or tail. So the total outcome, the total all possible outcome is called a sample space. All right. So sample space is the all possible outcome. Look at the all possible outcome. All right. And then if you toss a dice, well, a dice, you're going to have a face either 1, 2, 3, 4, 5, or 6. You're going to have a 6 possible outcome. So if you throw a dice, the sample space here will be 6, from 1 to 6. All right, so that is, identify the sample space of the probability like a broad types, right? So sometimes people call the type A, type B, type AB, and type O, which is a lot of people got a type O, right? But this broad type not only have these 4 major one, we also have a positive and negative. The RH positive and RH negative, okay? So what is a possible outcome? If we have 1, 2, 3, 4 different types, right? So we can have a type O, type A, type B, type AB, right? And then each one can have a positive or negative. Look at that. Each one can have a positive or negative, right? So how many different outcomes we have? Well, this is called a tree diagram. Actually, I'm already drawing a tree diagram here, okay? Because this is the broad type, right? This is the type, and then this is the different another the broad type of OAB or AB, right? And then this is either positive or negative. So we have a 4 major one times each one can also have 2. So 4 times 2 can be 8. All right. So what are those 8 possible outcomes? I can have a type O positive, type O negative, right? You do the tree, like going here, that's a tree. And I also can have an A positive or A negative, right? And I can have a B positive or B negative. Same thing as AB. I can have an AB positive or AB negative. Okay, so if you go to counter this one right here, I have exactly 8 different outcomes. But sometimes when this type getting in other different situations, not just only the broad type, right? In different situations, sometimes it can have a multiple, different types. And the way we count them is we just multiply, okay, not adding, but if you do the detailed tree, you can add them. But when we don't do the tree diagram, we just multiply them together. Okay, so 4 times 8, like that, 4 times 2 will be 8. So this is 4 type. This is each one have a 2 type. So 4 times 2, you will get an 8 possible outcome. And this 8 is called a sample space, right? This is called a sample space. All right, so this is a little bit clear diagram. Okay, so you have O, A, B, A, B, right? So you can do the horizontal one or you can do the vertical one, like the one I did in here. This one is doing the horizontal, so they are all good, right? So you have all positive, all negative, and similar to here. And this is the 8 possible outcomes. Okay, so this is we list this, each one is an element, right? We list all the elements in here, inside this bracket. Okay, so that's 8 possible outcomes. What is a simple event? Simple, that means you only have one outcome. Okay, so if you only have one outcome, it's called simple event. When an event has more than one outcome, it's not a simple one. Okay, so for example, if you tossing a head and loading a fluid, that would be H3. H3 is only one, right? So you this one is tossing a coin, either head or tail, and then you're rolling a dice, right? So the dice is 6 possible outcome. Okay, so the head can combine with the 6. The tail also can be combined with the 6. So 2 times 6. 2 times 6 we're giving you 12. Okay, so this is your 12 possible outcome in here. And then if we say, if you want a head and also a fluid, that is only one, right? Same thing if I say tail 2, the tail and its number 2 is also only one. So each one of these is only one. But if we want to say tossing a head and loading an even number, all right, so even number is more than one, right? Because 2, 4, 6, this will be all even number, right? So tossing a head, so this will be H, all right? And also the number are even. All right, so all these numbers are even. So this one is not a simple event because it has more than one. Okay, any questions so far? If you have any question, you can jump in. All right, you can jump in and ask. You can unmute you speaker and you can talk. I would rather to have your question answered right away than waiting until the end. Of course, we still have at the end to let you ask question. But if you have a question during the section, you can ask as well. All right, so let's look at this one right here. We want to determine this event is simple or not. Okay, for quality control, you randomly select a machine part from a batch that has been manufactured that day. Event A is selecting a specific defective machine part. So what do you think? Is this a simple event or not? All right, so this one is selecting a specific defective machine part, right? So I would say this will be simple, will be just one outcome because it's a very specific one. Okay. All right, let's look at the second one here. You roll a 6-sided dice. Event B is loading at least a 4. So what does at least mean? At least means can be 4 or more, right? So this event B loading at least a 4. It's a 6-sided die, can be from 1, 2, 3, 4, 5, and 6. So what does at least 4 mean? At least 4 can be 4, can be 5, can be 6. So this will have 3 possible outcomes, 3 outcomes. All right, so we have 3 outcomes in here. It's not just one. So this one would be not a simple event because it has more than one outcome in here. Okay, so that's how you identify simple or not simple event. All right. Keep it in mind, we're going to have a little bit quiz at the end of the section, okay? All right, so fundamental counting principle. As I mentioned earlier, if one event occurred in M way and the second event occurred in the N way, we can multiply all the numbers together using M times N. That will be all the possible outcome for the events. Okay. All right, so I usually tell people, say, if you go to the restaurant, go out to eat, right? And then they have a 3 appetizers in there. And then they also have a 5 entree that you can select with. All right, how about also have a 2 dessert? So how many possible outcomes you can have? How many possible combination you can have? If you have this appetizer, right? And then you have this entree, and then you have this dessert, right? So you have a 3 appetizer, 5 entrees, 2 desserts. 3 times 5 times 2 or 2 times 5 is 10 times 3 will be 30. So you will have a possible 30 combinations. All right. And if you want to go to drop all these possible outcome in a tree diagram, it will be pretty big. Okay, it's not possible, but it will be getting a little bit tedious that way. All right. So using this m times n, you can have a m times n times whatever OPQ, whatever, depends on how many sequences you have, right? You can always multiply all of them together, okay? So that is the fundamental counting of the principle in here. So look at this one right here. You are purchasing a new car, right? A good time purchasing a new car, right? The possible manufacturers, you have a Ford, GM, Honda, and then you also have a 2 different car size, compact or min size, right? And then you have all these 4 different color in here. So how many possible outcomes you can have? Anyone give me a quick calculation and then type it in the chat, trying to see how many different outcomes you can have. Okay, so let's see, how do we calculate the outcome in here? We have this is 1, 2, 3, right? So we're gonna have 3 times the car size is 2 times the color here is 1, 2, 3, 4. Okay, so 6 times 4 will be what? 24 for this one, yeah. Okay, so you're gonna have a 24 different outcome in here. So look at this one right here. This is giving you the tree diagram in here, right? So for the manufacturer, you have a Ford, GM, Honda, and then you have each one can have a two car size, okay? And then each one you're gonna have a 4 different color in here. So yeah, that is how you draw the tree diagram. But this will be 24, right? We said using 3 times 2 times 4. Giving you all the 24 outcome in here. So you can go to do the tree diagram just like that. Any questions? Any question on how to draw the tree diagram? We're gonna drop some later on, okay? All right, so using the fundamental counting principle, the access code for a car security system consists of 4 digits. Each digit can be any number from 0 to 9. So basically you have a 10 digit to choose from, right? 1 to 9 plus 0, so that's 10 digits, okay? And how many access codes are possible in false scenario? Okay, each digit can be used only once and not repeat. All right, each digit can only be used once and not repeat. So that means the fourth digit, I can have anything, right? The fourth digit here, I can have a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the fourth digit, I can have anything. I'm going to just say this fourth digit, I'm going to put a 9. All right? But I can also put a 0. So the fourth possible choice you can have. For the fourth one, you have the most choice, right? So the fourth one, you have all 10 possible choice. Okay? And or I can change this one, make it easy. I'm going to choose my fourth digit here is 1. Okay? And the fourth digit is 1. So this one is you can only use once, not repeat. Not repeat, what does that mean? That means this 1 is gone. Okay, the second digit I can only choose from the rest of this. So the rest of here will be only 9 choice, right? So if I choose this one is 2. Now 2 is gone. All right. And when I come to the third digit, how many there? Well, you have a 8 there, right? You have 8 there who can choose this for the third digit. So if for my third digit I choose 9, so 9 is gone. Okay. All right. So now you can, the rest will be for the fourth, the last digit here. 1, 2, 3, 4, 5, 6, 7. You have a 7 there, right? So the last digit you can have a 0, can have a 3, can have a 4, or either or 5 or 6 or 7 or 8, right? So if I choose 4, all right. So that is this one I didn't choose. This one I choose 9, right? So now I have a 1294 as my 1294. This is not repeat as my non-repeat 4-digit code. Okay. Sometimes if you use the electronic, the digital lock, right? Using a digital lock, if you try the first time incorrect, you usually have to wait. Some of them have to wait 30 seconds, okay, before you can try that again. All right, and some of them, like I said, a little bit faster. You still have to wait 10 seconds before you can try the second one. That way, let's using the 10 second for example. Okay, if I try the first code and it did not work, and let's say this is a 4-digit code, how long will I have to try all of them? You're gonna have to stand outside for hours. This is gonna be hours, if for several hours, in order to try all these different combination. Okay, so yeah, the 4-digit digital lock is secure. Okay, because if you see someone standing outside try to lock in your door, right, and then stand there for hours, keep trying, and I think a security or someone already suspects something, right? So you can see later on we will be able to multiply. Oh yeah, using this one multiply. So how many possible outcome we have? We multiply all this together. Look at that, multiply all this together. All right. So someone give this a little bit calculation. Multiply all this together. How much is that? I'm gonna multiply as well. Okay, because this digit getting to be. All right, so we have 7 times 8 is 56 times 9. All right, 5040. 5040. You're gonna have 5,000. You have to try 5,040 times. If you are unlucky, try the last one to be correct. Okay, and by the time you try the 5,000 times, you probably lost count already. You probably lost count. That you have to remember which one you already used, which one you didn't use, right? And think about it. This is 10 seconds. All right, each try is 10 seconds. Okay, and let's see how many seconds you will have. This is multiplied by 10. Okay, you're gonna have this many seconds. All right, so 1 hour is 60 minutes, right? And 1 minute is 60 seconds. So 1 hour is 36. All right, I am just giving you doing a math. Okay, they're gonna have to try 14 hours if we're using the 10-second rule. All right. So the 4-digit code combination have over 5,000 different combination if it's not repeat. Okay, and if you try the first time wrong, you have to wait 10 seconds, right? I'm just using the first one, 10 seconds to try the second one. You're gonna have to use 14 hours to try all of them. So what do you think? 14 hours, you already get off work or someone, it's already from morning, try all the way to the evening, right? Okay, so that is this one. So I think a statistic is very, very interesting, right? So you can do the math. Any question about this one? How do we calculate? All right, so that is the first one right here. That means do not repeat. Okay, let's look at the second one. Each digit can be repeated. All right, so now I am going to drop on the side here. So we're gonna have a digit 1, okay, digit 2, digit 3, and digit 4. Okay, so that's for the second one. Can be repeat. Okay, if this can be repeated, let's see how many one. I can have a 10 choice for the first one, right? Because look at the first one right here. I have a 0. I have from 0 all the way to 9, so that's 10 choice. And that means if so what? Let me erase this. If I did so, this 40 digits I can have. If this is 1, this can also be 1. This can also be 1. This can also be 1. So this is called repeat. Okay. All right. So the first digit I have a 10 choice. Since this can be repeated, this can also have a 10 choice. This also, each one of them can be 10 choice, right? I can have a 111 or can have a 222, you know, all those. So if you multiply this together, how much is that? That is 10 and 4 0, 1 and 4 0. That's 10,000. That's even more than this is 5,000. If you don't repeat, you're gonna have a 5,040. If you can repeat, this will be 10,000, even more. Yeah, of course, if you can repeat, you have a more choice. Okay, and this is gonna take more than 14 hours to try the code. If you can repeat, that's even more, right? So that's how you do the counting in here. Okay, the third one a little bit tricky. It said each digit can be repeated, but the fourth digit cannot be 0 or 1. Okay, so how do we do this one right here? All right, so let's do another one right here, right? So now this one we're gonna have a digit 1, 2, 3, and 4. Okay, all right, so similar, we are gonna have a 4 digit in here, but it said this one, the fourth digit cannot be 0 or 1. So if you cannot be 0 or 1, what else can you choose? You're gonna have a 2, 3, 4, 5, 6, 7, 8, and 9, right? So how many digits do we have for the first one? This is gonna have a 8 digit, right? Because you have a 0 to 9 is 10 digit, and then you exclude the 0 and 1. So you're gonna have a 8 choice for the first digit. This can be 2, 3, or any one of these. So that's 8 choice. Okay. All right. And this one, it can be repeat. So the second one, I do not have a restriction. So this one can be 10 choice, right? So 0 to 9, that's 10 choice. Same thing as the third digit, I can have a 10 choice. I can have 10 choice. So this total will be 8,000 choice in here. All right. Any questions? Any questions about this one? How do you calculate this type of scenario? No questions? Okay, all right. We will have some time to let you practice later on. Okay, so type of a probability, we have one called a classical probability. Classical is also called a theoretical probability, right? I actually just asked you, if you flip a penny, okay, what is the probability of getting a head or tail? And all of you have some people say 1/2, some people say 0.5, some people say 50%. These are all correct, okay? So basically, and then the same thing as a tail, you can also have 1/2 or 50% or 0.5, right? These are all equal, right? And this, the one you're talking about is called classical probability or theoretical probability. This one is in everything is in a perfect condition, right? Everything is perfect, and every outcome in a sample space is equally likely to happen. Okay, and like I said, when you flip a coin, you're gonna have half time, 50% of the chance you're gonna get a head, 50% of the chance you're gonna get a tail. This is theoretical, okay, or classical probability. And we do calculate quite a bit of this kind of classical probability, okay? So this one is using the number of the outcome in the event E divided by the number of the outcome in a sample space. So the sample space is the total possible outcome, right? This is a total possible outcome called a sample space, okay? So since you toss a coin, you only have one head, and the sample space is 2. So that's why you're using 1/2. Okay, so look at this one right here. You roll a 6-side die, okay, and then what's the event A rolling a 3? What is the probability? So now we are looking at the probability. So you only have 1 3 here, right? So you only have 1 3. So and then your possible outcome is 6. So it's 1 out of 6. Okay. Or sometimes say we're gonna look at in here. Probability rolling a 7. Do we have any 7 here? No, we don't have a 7 here. So that's 0 out of 6. So that's 0. Okay. Loading a number is less than 5. Well, less than 5 didn't include 5. Okay, less than 5, so it's 1 2 3 4. All right, so this probability will be 4 out of 6, and you do need to simplify. If you kill a fraction, you have to simplify. You have to divide it by 2, right? This is all even number can be divided by 2. So numerator and denominator both divided by 2, you got a 2/3. So you do need to simplify. Okay, if you do not know how to do the simplify, I'll show you using a calculator to simplify later on. All right, so that is how you calculate this type of called classical probability. Okay. All right, empirical probability. So what is the empirical? The empirical probability sometimes also called a statistical probability in here. Okay, so that is the one I usually tell people, say you go to do a little bit of coin flipping at home, and then I want you to flip 10 times. Okay, and then how many times you got a head, how many times you got tail, right? And then we have a group 1, and then we have a group 2, and then we also have a group 3, and then they usually come out with different outcomes, right? So I did this one in class before. Some people say I got 5 and 5 perfect, they got 5 and 5, but most people don't get a 5 and 5, right? So sometimes people got a 6 and 4, sometimes people got a 7 and 3, right? So that is called empirical because you do the real experiment. Okay, you do the real experiment. All right, so that is the empirical one. So if I want to calculate the group 1, what's the probability of getting ahead, right? For group 1, this will be 5 out of the 10, or 1/2. For group 2, probability of getting ahead will be 6 out of the 10, or 3 out of the 5, right? Probability of group 3 to get ahead will be 7 out of the 10, something like that. Okay, so that is how you calculate empirical probability. After class, you can do a little bit experiment on your own first. Okay, and then sometimes people say, oh, how about this? Now we have this empirical probability. Does this one contradict with the theoretical we talked about earlier? All right, and then that's why we have one thing is called law of large number. Okay, I'm gonna just pull that ahead. Law of large number. Okay, what is the law of the large number in here? That means if you only flip 1 or 2, or if you only flip 10 times, you don't always get a half and half head, half tail that way. Actually, if I have a 5 or 6 group, usually in a class, probably only one group, maybe one group. Sometimes I don't have any group, got a 5 and 5. Okay, so because the number we try in here is pretty small, it's only flip 10 times. If we flip more and more times, like actually there's a rake, someone have a rake, flip the coin for 68 million times. 68 million times. Okay, when they flip 68 million times, and then they do the statistic, they do the counting, the number of head and number of tail, they come out really close to 50 and 50. And that is called the law of the large number. Okay, so if this number is large enough, this empirical probability, we are getting closer to the classical or the theoretical probability. All right, so that's called the law of the large number. If we only flip 10 times, that's too small, right? So you won't get close to half and half that way. All right, so this empirical probability, sometimes people doing the survey, you doing the paper survey, or you can have an online survey, right? Those actually is doing the empirical probability. Okay, so this company is conduct the online survey randomly select US adult, right? To see how they read the book during the past year. In here, so they have surveyed 1,490 adults. Okay, and then this is the pie graph represent 1,400 adults. So you can look at this pie. We have 395 people say they don't read any book at all. All right, and then some people 578 they said they only read the print out books. Okay, this is probably an old survey. Read both print and digital book, read only digital book 91, right? So I think I'm reading more and more digital books at this point. So this I would say, oh, that's 2016. All right, so that's 2016. Now we are in 2025. Okay, so I'm sure this digital book getting more and more popular. Okay, so you can do the calculation. How many of them read only digital books? What's the probability that people only read digital books? So give you a quick calculation. How do you calculate this one? Okay, so only about 60%. Look at that. Right? If I use this one, I insert a percentage. All right, so if I run to the integer, that is about only 60% of the people reading the digital book. All right, or 0.0 get rid of percentage. All right, so it will be 0.006. Okay, so that is how you calculate the empirical one. All right, so the n here, actually you don't have to do this one because this is says survey 1,490, so that's my total, that's my sample space, right? This one is saying you're gonna add all of this together, but actually if you read the question carefully, it's already telling you here. All right, and then if you want to read only print books, right? So only print, this is read only the print books. 578, right? 578 read only the print books. So only read the print books is this one. So it's 38, 0.388 or 38.8% people will read only the print books. All right. Okay, so you can also look at this survey in here. This is a phone survey, right? 975 social networking site users have been surveyed. Okay, and the frequency distribution showing this one right here, we want to see what's the probability that the next user survey will be 23 to 35 years old. All right, so if you look at 23 to 35 years old is 312, right? And then if you look at the total here, well, this one add up the total is 975. So this frequency add up together, but it also tell you the total in here. So if we use the 312 divided by 975, right? That will be 0.32 or about 32%. Okay, that way. So the next survey will be between this age will be 32%. All right. And this is the law of the large number I was talking about earlier, right? So, if you do this experiment, repeat over and over again, and when it getting really, the number of the trials getting really big, this empirical probability, we are getting very, very close to the theoretical or the classical probability. All right. So like I said, if you flip this penny 68 million times, not 68 times, but 68 million, okay, you will getting very, very close to head and tail 50-50 right here, right? So if you only have a less than 30, look at that, it's all over in here, okay? This is all over if you make it a little bit bigger right here, right? Below 30 times, look at that. Some of the head, probability they're getting heads, right? Some of them will be 0.7 something percent. Some of them is only 3 something percent, right? So it's all over everywhere. And then when this number getting bigger and bigger, look at that. So this charge, this valuation is getting smaller, okay, and getting a little bit more consistent, over the time in here. All right, but below 30 times, this is definitely everywhere. Okay, so that's called the law of the large number in this case. All right, the third type of probability is called a subjective probability. Okay, so what is a subjective? It's based on educated guess and estimate. Okay, a doctor can predict a patient's survival rate or full recovery rate, right? So the doctor may feel a patient has a 90% chance of the recovering from some kind of cancer or whatever, or broken bone or whatever, right? So those are the based on the educated guess. All right, and that is called a subjective probability. So we have a 3 type of probability in here, right? Empirical, which is based on the real experiment or survey, and classical, also called a theoretical survey. It's just everything is perfect based on theory, right? And then this one is kind of based on guess. Okay, this guess is not everyone can guess. You have to have an educated guess. All right, that kind of thing. So that's called a subjective probability. Okay, so another subjective probability here is all right. So if we set the probability that you will get an A on your next test is 0.9, what do you think of this probability? Okay, so this one I will say this is probably, the if you let me guess at the beginning of the semester, right? At the beginning of the semester, since I still didn't know you and you haven't completed any assignment, and then if you want me to guess your course grade, I probably won't be able to guess, right? But after a certain point, probably by at least half of the semester, right? And I can look at your homework assignment, and I can look at your test 1, test 2, test 3 grade, right? And by that time, I might be able to predict, like I say, how much you will get in this course, But that is based on all the data you have, all right? So that is not a subjective probability. This is based on the homework, everything you assign already, you complete already. So I would say that is probably the empirical one, okay? And probability that a voter choosing at random will be younger than 35%, will be younger than 35 years old is 0.3. Okay, so what kind of probability would be this one? All right, so this one, I also said this one, they probably have a previous data. All right, just like the one we have in here. Let me show you this one. This one we're talking about. Okay, this one will be similar to have this one right here, right? So they usually have a little bit of data to indicate like the age, right? Okay, how about like the draw for ticket? Probability of winning a 1,000 ticket draw for the ticket is 1 over what? 1 over a 1,000. All right, so this one is pretty clear because looks like you have 1,000 ticket, right? If you have 1,000 ticket, and then the probability of winning the ticket here is 1 over 1,000. This is based on everything is equally likely to happen. All right. So if based on everything based on equally likely to happen, which is exactly 1,000 ticket, you have a 1 over 1,000 chance to win. So that is the classical or the theoretical probability. Okay, so this one probably the easier way to guess, to identify, because it's based on theory that way. Okay. We said earlier, probability, the range usually is between 0 and 1. We don't use the negative number for the probability. Okay, do not use the negative number for probability. And we also do not using like more than 100% or more than 1, right? So if you have a probability equal to 1, that's for sure, certainly gonna happen. We said tomorrow it will be 100% sunny. All right, so that means there's no rain change at all. Okay, so that's certain, that's 100%. All right, and instead the chance of raining tomorrow is 0. Well, the chance of raining tomorrow is 0. That means it's 0. That means it's impossible. That means it's not going to rain at all, right? So that is in here. 0.5 is kind of half and half, right? Less than 0.5 usually called unlikely, especially you have a less than a quarter chance. It's pretty called very unlikely. All right, and if you have a more than 0. More than 75%, we usually call very likely, right? Or just likely between 0.5 to 0.75. Things like that, right? You can emphasize how likely that way. All right, but definitely knowing the probability is between 0 to 1. Okay, now we're gonna look at some of them called a complement event. So what is a complement event? Okay, let's look at the complement event in this way. If I say the chance of rain tomorrow is 10%, all right, what is the chance of not rain tomorrow, everyone? Well, the chance of not rain tomorrow will be 90%. Okay, so that is called a complement. That means you only have a 2 category. All right, if I can categorize as rain or not rain, that'll be only two parts, right? And then 2 parts added together will be always 100%. So that's called a complement event of the E. And then the outside one we call the E prime. Okay. So the probability of E and E prime added together should be equal to 1. Or you can use 1 minus the other one for the current one. Okay, so that's complement event in here. All right, so look at this one right here. If we want to have a social networking site user age, this one is say you want to choose the group probability. You want to find a probability that is not between these two groups. Okay, so that means we want to select that group. All right, so if we don't want this group, we can have this group 1, 2, 3, 4, right? I can go to add all these 4 together and divide by the total. Or I can just simply using 1 minus this group. 1 minus this group. So this group probability will be 312 over 975. Okay, and this one will be a little bit easier to calculate than your direct calculation. So your direct calculation, you need to add 156, 254, 195, or 158, and then divide by the total. So look at this calculation. This is much longer than this. All right. So, but these two, we are giving you the same answer, basically. All right. So this is how you do the, using the complementary to do the calculation, right? You can use 1 minus that the age is in this group. The rest will be not in this group. Okay. So you can do either way. If you like the direct way, that's fun. But I personally like this one because this got less number to calculate. Okay, and another one here is how do we draw the tree diagram? Okay, so yeah, in this section, some of them when you're doing this kind of statistic, you also want to do a little bit tree diagram, right? This one is probability experiment consists of tossing a coin and spinning this wheel. Okay, this is a spinner in here. And this spinner is equally likely to land on each number. So you have 1 through 8. Okay, so I have 8 outcome in here. Okay, and we want to toss a tail and spin the odd number. Okay, so you flip a coin, right? So a coin will be either head or tail. All right, and then each one you're gonna have 8 number. Okay, let me drop a horizontal way this time. Okay, so we're gonna have a head, and then we have a tail, right? So this one you're gonna have 1, 2, 3, 4, 5, 8. All right, so I have 8 in here, and then the same thing as a tail. I also have 1, 2, 3, 4, 5. Okay, so this one you have a H1, right? So if you write down this one, it will be H1, H2, all the way to H8. Okay, and then this one will be T1, T2, T3, all the way to T8, right? The tail 8. Okay, so let's see how do we answer this question. Event A, you're gonna spin a tail, okay, and also an odd number. All right, so how many odd number do we have? So that's T1, T3, T5, right? And then T7. Okay, so we have this we have these 4 possible outcome. Okay, and then let's see what is you want to find a probability. Okay, using a probability. Probability is not only just counting the outcome. Probability here is you also have to divide it by the total. All right, so you're using the number of the outcome divided by the sample space, or sometimes I just call it a total. Okay, so how many totals do I have in here? If I have a H head, that's 8 plus tail, also 8. So my total here, spinning this one, spinning a coin, tossing a coin, and spinning this spinner, I will have a 16 outcome. Okay, all right. So the first one right here, I will tossing a tail, and an odd number. I will have a 1, 2, 3, 4 out of 16. or 1/4. Or if you convert it into decimal point with 0.25, 25% of the time, right? Second one, tossing a head or speeding a number is greater than 3. Okay, so this one getting a little bit tricky. All right, this one is an and, this one is an or. Okay, so now we will look at the or. What does or mean? Tossing this one ahead. Okay, so tossing this one ahead. Tossing ahead. How many head do we have in here? We already have a head 1, head 2, head all the way to 8. So that's A outcome with a head, right? Or spinning a number greater than 3. Okay, so that means if I have a number greater than 3 also count. So what number greater than 3 doesn't include 3. So I have a 4, 5, 6, 7, 8. If I have a tail, we also count. Because this is or, this is not an and. Okay? Or that means if I have a head, that's enough. Or I have a number greater than 3, also enough. So that means I can have a tail and also greater than 3, and it still count. And then this is 1, 2, 3, 4, 5. So I have an 8 plus 5 divided by my total, which is 16. And then you can go to divide this one. You can do whatever. 13 divided by 16, right? So that's 0.8125. Okay, so that's how you calculate this type of tree diagram, calculate this probability. So the only thing difference for the probability is you just have to divide by the total. Okay, and my total here is 16. Any questions so far? I know we cover a lot of concept in here about probability already. Any question? Okay, so look at this one right here. I think we already calculated this one earlier, right? So we have a possible outcome here is 16, okay? And event A here, event A, you want to have a tail and also an odd number, right? A tail and an odd number. So tail odd number is T1, T3, T5, and T7, right? So we have a 4 out of 15, 16, 4 out of 16 or a quarter, or 0.25, right? So that will be this one right here, okay? And then the second one right here, you're gonna have an event. Event B is a head or something greater than 3, right? A head. So that means all these head will become, and anything greater than 3. Greater than 3. Okay, I think this one is. That's greater than 3 right here. Okay, that's for this one. So 4, 5, 6, 7, 8, they are all greater than 3. Okay, so you have an 8 plus 5 will be 13. 13 divided by 16. That is your sample space in here. Okay, all right. So that is sometimes draw a tree diagram is very easy to help you to identify. Okay, any questions so far? I know this is a long section already. All right, we will also cover another section because this is a little bit condensed section, right? A little bit I'm gonna cover one more probability, and then we will go get a break. Okay. All right, this section is called a multiplication rule. Okay, the conditional probability and also the multiplication rule. So we need to determine a dependent and independent event.